Thank you. All right, so I'm going to talk about loading. It's not something we probably like to think a whole lot about. It's not one of the more glamorous things. Typically, we're building apps or we're building sites that have interesting content, apps that have compelling functionality. But we all have to think about loading. And I guess I'm here to deliver the message that we all need to think harder about loading. So first, quickly, let me introduce myself. I work on the Polymer team at Google, which is part of the Chrome organization. So we work on a library for building web components and building apps out of web components. But I'm not going to talk really about Polymer much at all today. Instead, I'm going to talk about something that's really a major focus for the Chrome organization on the whole, and that's how we really improve the state of the mobile web, since that's increasingly what the web has become, by building apps that load better and faster and more reliably. So, how is the mobile web anyway? Unfortunately, not so hot in a lot of ways. Now, of course, you know, if you've been doing web development for any length of time, you can do things on the mobile web now that, you know, you couldn't have dreamt of doing, you know, several years ago. I mean, in terms of capabilities, you know, it's really grown in leaps and bounds, and you can do just about anything in a mobile web app that you can do in a native mobile app now. But we have a little problem with performance. First, apps are super crazy slow to load. Let me try and put some numbers behind this, because I think we all have this perception that, you know, mobile web apps don't load as fast as native apps, and that perception is absolutely true. And unfortunately, our perception is actually maybe skewed because a lot of us, I'm willing to bet, are carrying around iPhones or, you know, high-end Android phones, and we live in a place where, you know, we're sort of spoiled by 4G connections. But in a lot of places where people are accessing the mobile web, and especially in places where the next, you know, billion users are coming online, that's definitely not the case. So we're trying to do a bunch of data collection around exactly how big the problem is. These numbers I'm sharing are based on a study that we haven't published yet. It's not terribly formal, and I'll talk a little bit at the end about sort of what we're doing and how we're trying to get data out. But these are high-level numbers that were gathered recently by a team in Google Developer Relations, looking at 5,000 websites. These websites are things built with, you know, current technologies, new, you know, current libraries and frameworks. And these are median numbers for those 5,000 apps. So for these 5,000 apps on a 3G connection, the median website takes 7 seconds before you get a paint on the screen that shows anything meaningful at all. 14 seconds to the document complete event, and 18 seconds before the app is interactive and ready to respond to input. Obviously, there's a bunch of web apps out there that do somewhat better than this, but again, this is real data, real sites collected within the last couple of months on a mid-range, you know, mobile device over a 3G connection. And so that's not good, right? But it gets worse when you look at this data, which came recently out of DoubleClick. A lot of you probably saw this. 53% of users will bail out on a mobile website if it takes longer than 3 seconds to load. And so, you know, what these pieces of data are telling us is that, you know, a good percentage of intended visits to mobile websites are ending up going nowhere. And, you know, if like me, you've been working on the web for a long time, you want to see the web win because you don't want, you know, the way the world does computing to be operating in a few silos owned by, you know, a few companies, you know, this is all really bad and something we all need to work on fixing. And then, you know, that's just, you know, loading time. The other problem, of course, with the mobile web, you move from place to place, step in and out of elevators, you know, walk down the next block, and you're between a tall building, and your network connection goes, and oftentimes, you know, you end up with something that looks like that. And that's not good either. So all of these things are really related in a way to the way we load and cache our applications and the way that we respond to user requests on the client. So why are things so terrible, particularly in the performance area? So I think I'm loosely quoting my colleague Alex Russell here. I couldn't find the exact quote, but the bottom line is that our mobile devices and networks basically hate us as developers and, frankly, as users. So what do I mean by that? Essentially, the deck is stacked against us. Obviously, the networks themselves are not nearly as fast as our wired networks and our the networks we use from our desktop devices. And we just talked about flakiness as you move around. CPUs in our mobile phones, if you look at the specs, they're actually pretty powerful, pretty impressive. But there's a talk that I'll tweet out or I'll share with the slides that Alex Russell did recently a couple of times. He gave a version of it at Polymer Summit a couple months ago and then another at Chrome Dev Summit, in which he explains why those numbers are lies. So basically, in order to prevent the mobile phone from burning a hole in your pocket or draining the battery, in an hour, the actual performance of those CPUs is throttled way down. And there are even some interesting assumptions that are made on mobile devices. Typically, deep in the OS layer, they do things like when you tap on an app in the launcher, they will crank up the clock rate on the CPU, assuming that you're going to do something. The app's going to launch, something expensive is going to happen. But the mobile web kind of works against that because typically the first thing you do when you launch a browser is you make a request to the network, and you may wait several seconds for that, and meantime the CPUs clock back down. So anyway, there's all of these things that conspire against the mobile web, which really means that you can't leave any performance on the table. And the problem is that we are leaving a lot of performance on the table. If you look at the way we build our apps, they are by and large, the reason why we're seeing those terrible numbers is because we're not approaching this problem with a full recognition of it. We're using techniques that have worked for us on the desktop, where we have abundant computer resources, abundant network bandwidth, and we haven't updated our approach to deal with the reality that mobile presents us with. So to dig into that slightly more, and this is going to be a really sort of gross generalization, but I'm going to point out a couple of things. One is, again, because of the abundance of resources on the desktop, and because of the fact that we now have modular JavaScript. So it used to be, we sent down static HTML pages all the time with, a couple of scripts, some images, but we now have, at our disposal. First of all, the stakes for what our apps do have gone way up. We need to be delivering amazing functionality, and in order to deliver that, we have turned to this burgeoning ecosystem of awesome modules that other people have written for us, and we can grab them and cobble them together, and before you know it, you have megabytes and megabytes of JavaScript source code. So we got away with that on the desktop because of the abundance. Bottom line is, a typical app will now have multiple megs of code even before you start thinking about content and media. And similarly, besides just the fact that it's really big, we also have developed this way of delivering apps, which is we put everything in a gigantic bundle and send it all down. And again, that's because our apps have gotten more ambitious. It's because again, we're grabbing tons and tons of modules. But we also historically have had to live with some really serious constraints imposed on us by HTTP, the protocol we use to send stuff down the wire. So as you know, HTTP 1, it basically required a new connection for every request, and it was all done serially, so you couldn't have multiple requests in parallel. And as a result of that, as things got more complex, we developed, we realized in order to have any hope of doing that efficiently, we would have to jam everything into one big file and send it down. So we only paid the overhead of the transport once instead of multiple times. So this worked pretty well for the desktop. But fundamentally, if you are in a resource-constrained situation and you want maximum performance, bundling fundamentally just kind of sucks for a few reasons. One of them that really bites you, as it turns out, on mobile, is that when you send down a gigantic bundle of JavaScript, that JavaScript is going to be, first of all, you have to wait for it to come down, and so the network transfer is, takes a long time for a big file. But then once it gets there, all of that JavaScript effectively gets parsed and evaled together at once. There's no breathing on the main thread, and so we're looking at a mobile site here, and you can see there from about 4 seconds to 12 seconds or so, that's the main thread locked on parsing and evaling the main bundle for this application. And that's sadly all too typical. And it's something that happens as a direct result of the fact that we're just sending down one gigantic chunk of JavaScript. The other problem with bundling is that it's impossible to do it optimally, or it's darn hard to do it well at all, and it's impossible to do it optimally. So this is that big bundle of JavaScript, and you'll have to forgive my crappy graphics. So, one of the ways to get around the one big bundle problem is to do code splitting. So you split your bundle up into multiple pieces. So in theory, that looks like this. I maybe have 4 entry points in my app, and I split it into 4 equal-sized chunks, and it all works nicely. But it never looks like that. What it ends up looking like, you can do a couple of different things. One is each bundle gets everything it needs, and you just live with the fact that you've got redundancies across entry points. So, each of your bundles grows to the point where you're now sending the same code down multiple times every time they hit a different endpoint, and that negates a lot of the benefits of code splitting. And the other approach is, each endpoint has its own bundle, but those tend to be pretty small. And when you hit that first endpoint, you also get this massive common thing that looks a lot like that original big bundle. And people are getting smarter and getting clever about how to do bundling, but no one's really solved this. And frankly, it is I'm not betting on anyone getting great at this because it's just a hard problem. And then don't even start thinking about caching. So, there are sites at Google, and I won't name any names, that are sending stuff down in one gigantic bundle, so several megabytes, and they're shipping 2-3 times a week. You go on Monday and you download several megs, and you go again on Wednesday and you download several megs, and maybe 1% of what was in that bundle changed, but it totally defeats the mechanism that the browser has for caching. So, what do we do instead? So, in theory, wouldn't it be great if you could just write your app, use all the modules you want, pull them from wherever, write your own modules, take your directory structure, plop it up onto the server, and just allow the browser to serve it at something like the granularity at which it was authored. Sounds pretty good, right? And you're probably aware of HTTP2, and that was supposed to sort of unlock the potential of something kind of like that by allowing a single connection to be used for a session between the client and the server, and allowing multiple streams to go in parallel. But you see there's an asterisk there. And there are several problems. So it turns out that the compression algorithms we use to greatly reduce the size of what we send down work really well with one big long file, and they work like crap if our files are if we have multiple files. And probably more insidiously, once we had HTTP2 in place, really all we're doing, we've removed the bottleneck at the top of the funnel. And as you might expect, there's tons and tons of code across different browsers that have really never properly been exercised because everything was always coming down in one big bundle. So, for example, we discovered when we were doing some work recently that there were inefficiencies in the disk caching mechanism, such that if you were loading a bunch of files, the writing to disk cache actually became the bottleneck. And it turns out, worse than that, the code inside of the browser engine was not delivering resources to the rendering engine until after they were done being cached. So basically everything ground to a halt once you got past a certain number of files. And that's just one example of many. So, and then there's the fact that even if a lot of those problems were solved, today's apps tend to be quite large and have lots of small modules. So there's one of the things that was surprising to me when I joined the Chrome team was to find that there's really not consensus even within Chrome as to how well we can solve the many small files problem. So bottom line is just lots of question marks about this. So we're not going to leave bundling behind anytime too soon. There's no magic sweeping solution that's going to save us within the immediate future. But there are things that we can do and things that we should all try to do. So I'm going to run down a list of things. This is where we start getting a little more opinionated. And so before I jump in to this list, none of this is the gospel. This is a well-considered opinion and sort of the beginning of a dialogue that we really want to be having with the entire web development ecosystem, because there are things here for us all to do. So thing one is test on real devices and networks and do it from the start of your project. Far too often you see sites that are developed and tested entirely on desktop, and then at some point as you're getting ready to launch, someone pulls out a mobile device and looks at it and it's like, oh, this is really bad. Sadly, that happens far too often. So you can get for about $150 a mid-range Android phone, and if you take that phone and you use it on a real 3G network, and you use that again from the earliest stages of development, and you don't allow yourself to suck, then this will result in much better performing apps. If you don't want to spend the $150, check out webpagetest.org. It's not really a substitute, but you can go and you can basically make a request at this site to test your app on a whole wide range of real hardware, ranging from desktops to phones and such. So, and you can actually download the trace and look at it in your own inspector. If you haven't used webpagetest.org, definitely do it and use it to test the slow phones. Use other testing tools. Most of you are probably doing this. Obviously, the in-browser dev tools, most of them now have the ability to simulate throttled network connections. Some of them actually do simulate CPU throttling. The numbers are not what you would actually see in the real world, so this is not really a substitute, but it's far better than not doing it at all. So definitely do that. At Google, we also are working on a tool called Lighthouse, which is specifically it's looking at a number of performance metrics that sort of correspond with the data we were talking about up front, really a focus on time to interactive. And it'll also score you in a bunch of other interesting things around whether you're building a good progressive web app. And I won't do the whole progressive web app spiel because I'm sure you've all heard it before. And then, of course, page speed insights. These are all tools most of you are probably using, but live by them. So besides testing, use the latest features of the tools and frameworks that you're already using. So one of the mitigations that has been increasingly used for single-page apps is server-side rendering. So take the same code that we're using to build the UI on the client, run it on the server, send that down so that while your main thread is locked for 10 seconds processing your JavaScript, at least your users can be looking at something. And it, definitely good. It's it's not a magic bullet. Because if the main thread is locked, the user still can't do anything, and that's what we're talking about when we talk about the uncanny valley. It looks like an app, but it's not really an app yet. Code splitting. Again, if you're using Webpack or whatever your whatever your tool of choice is. The popular ones are now doing code splitting in various flavors. Again, all of the issues, theoretical limitations of bundling and code splitting apply, but do it because it's better than not. Tree shaking, also good if you're using ES modules and you have a tool that will allow you to discard code that doesn't get used and leave it out of your bundle. Definitely do that. To deal with network reliability issues, definitely use a service worker so that once your app spins up, service worker comes up in the background, loads additional resources required to enable your app to work offline. And that actually can help dramatically, obviously, with performance on repeat visits as well. And so, as we get progressively down the list here, some of them are super simple, and some of them start getting more radical. And this is one of the more radical ones. This term means something in actual finance, and I'm sort of abusing it. But the idea is you need to justify the cost of everything. And I think too often, it's really easy to grab things and toss them into your app because it solves a problem you have without necessarily recognizing the weight of what you're pulling down. And so just really be super conscious when you grab a new module, when you choose a framework or library, what the cost-benefit ratio is of what you're doing. And I'll talk in a moment about how I think tools can help us with this. I won't go into this in a lot of detail right now. I will, again, share a link to some resources about this. But purple is the name of a pattern that we came up with on the Polymer team. It's not specific to Polymer at all. That's obviously where we started it. But it is basically a way of structuring and serving apps that adheres to a certain pattern. The letters stand for push, render, pre-cache, and lazy load. And so I'll very briefly explain what that means. So push doesn't necessarily mean HTTP2 server push. What it means is don't wait for the sub-resources for a given entry point to be organically discovered by the client. Instead, do something. Use link rel preload, even just inline stuff to ensure that the resources you need come down with the HTML page for your first request. And then once they're down, and don't send anything more than you need either. And this is where it gets tricky. But send just what you need. Render the first view that corresponds with that endpoint. Once that view is rendered and your app is interactive, you spin up a service worker, and you begin opportunistically pre-caching the resources required for the rest of your application. And then as the users actually take actions and navigate within your app, only then do you lazily load those additional resources out of the service worker cache. So at that point, you're not hitting the network anymore because they've already been pre-cached. But you lazily load them, and it's at that point then that they get parsed and evaled, so that after they've landed on your page, all subsequent actions are much faster. So it's a pattern that makes use of modern features like service worker, potentially like H2 server push if you have a server that supports it and you're targeting clients that support it. And again, it's really a topic that deserves half an hour on its own. I'll send you a link. But obviously, app developers can't do all this themselves. So tool vendors, browser vendors need to do stuff as well. And to summarize, effectively, we need to make it so that it's fast out of the box. Right now, if you follow your nose, it's really easy to go off the rails and build something really slow. And I think it's incumbent upon tool vendors, framework vendors, and browser vendors to make the default way of building stuff faster. So the rest of this is sort of some specific ideas of things we can do. So first, more and better performance tools. Google's building a couple of them. I think there's room for a lot more innovation here. Smarter bundling. Again, it's kind of a hard problem, but I think that there are things. One thing that bugs me about the way we're trying to do code splitting is that it's sort of top down. So you have everything that's required for all of your application code effectively ends up getting bundled along with a bunch of framework and library and third-party code underneath, with the result being that all of your volatile app code basically gets bundled together. The top-down approach basically means that your most volatile code is the stuff that's getting bundled. I think there are ways to bundle more from the bottom up, so that your dependencies, which you're changing much less frequently, are the things that get put together, and your volatile code is served in more granular fashion. Tools aren't really doing this yet, but I think that's where they need to go. And that's one idea. I'm sure there are many others. But more fundamentally, I think the tool vendors need to stop thinking of themselves as providing bundling first and foremost, and instead think of themselves as providing sort of project management and build, where some of what it outputs may be bundles, but fundamentally what they're doing is they're helping you select and install dependencies and giving you an idea of what the cost of those dependencies are, and walking the dependency graph of your application, and then doing something smart with it, which might be some bundling, but not always. As far as framework and library developers, this again is a little biased. Our deal on the Polymer team as part of Google is that if you use more of what the browser gives you, and then you don't have to bring so much that runs over and above the browser. So get smaller. And I think there's plenty of actually examples where, for example, Preact and Inferno are examples of libraries that are based on the React approach and the React APIs even, but that are specifically focused on being as small and as lightweight as they can be. And Vue.js is another really great lightweight library. Also, get more modular. Again, if you are going to sort of bring the kitchen sink and give the developer everything, figure out how to make it more modular, so that I'm not pulling down one big mega framework. I'm pulling down the pieces of the solution that I need. As for browser vendors, like Chrome itself, I do think that the long-term vision we should be chasing is something like that unbundled one. And so, at Chrome, we are looking at how we can drive the overhead of multiple files way down, so that in some future nirvana, we can be doing little to no bundling. Specifically, we want to improve the efficiency of compression in that case. There's a bunch more interesting new use cases that have been contemplated for service worker that will enable, for example, there's foreign fetch, so that you can have your site, if you are providing a library or a shared resource, you can have a service worker that can be hit by sites that are consuming your library. Right now, a service worker is specific to your site. And so if I'm using React on my site, my service worker is responsible for caching the version of React that I'm using. With foreign fetch, someone, CDN, could have a service worker with common third-party things, and we could effectively share cache across multiple sites. And a bunch more. So, as I said, this is sort of item number one inside Chrome right now. We really care to make the web fast. We want to see the web win, and we think that there's work that needs to be done by everybody, and we don't think of this as a Google thing or a Chrome thing. So within the next week or two, we're going to sort of unveil in really raw, work in progress form a lot of the thinking we've been doing and start taking conversations that we've been having internally more externally. And so we've coined this term. Can't guarantee that it's not going to get replaced in the next few days before we launch it, but we're calling it sustainable loading. The idea being that we're in a broken place where we're not as conscious of resources as we should be, and we need to come up with new approaches to loading that take the web to a better future. So I think you'll see that term be something that we throw out there, something that we want everyone to think about. And we'll be launching, again, name and logo highly subject to change. But we'll be launching a blog, probably actually a Medium channel, where we'll start tossing out stuff of various kinds, sharing ideas, sharing data, and also inviting other people to come and join the conversation. Our idea isn't that this is a soapbox for Google. It's let's take this conversation public about how we improve the state of loading. So a little bit of a sneak preview. This stuff will be coming in a matter of days and weeks, and I hope that you guys will join us in that conversation to the extent that you're interested. So, with that, if there are any questions, I'm happy to answer them. Yes. Yep. Yeah, I mean, that's definitely an angle that that we are discussing, and I think there's potential there, whether it be map files in their existing form. Certainly all of the tools that we're using for bundling today are effectively generating a lot of metadata that ultimately doesn't make it to the server, doesn't make it even to the, therefore to the browser. And so, yeah, absolutely, conceptually, whether it be map files or other forms of metadata that would enable the browser to be smarter about how it caches, absolutely. And there's actually a bunch of stuff going on, like there are cases where V8 and other JavaScript engines, I presume, are actually caching compiled code, but that isn't happening necessarily nearly as optimally as you'd want it to, and there's very little transparency to the developer as to the circumstances under which that happens. And so, there's this thing is many, many layers, and there's things that we can do at almost all of them to improve the state of things. All right, thanks.